Yeah, good evening, everyone. I'm Abhishek from SmartBridge. I'll be dealing with Java Spring Boot tag. So we'll wait for another 5 minutes till all the participants join. So until then, if any of you have queries, while installing yesterday's prerequisites, so yeah, please let me know through chat. Good evening, Satish. Good evening, Pavitra. Yeah, you need to install JDK 11 beta. Good evening, Srinivas. Okay, I'll just recall, Pavitra. So today's prerequisites are going to be, you need to have a STS ID installed, right? STS basically means Spring Toolsuite. You also need to have a JDK 11, right? So those two are the main prerequisites. Docker you can install in the coming sessions as well. Yeah, yes, we'll start within 3 minutes. Okay, we'll still wait for another part for few more participants to join. Good evening, Avdesh Sharma. Good evening, Karina. Yeah, Pavitra. So today we'll be having both theory and as well as practical. We'll be doing a hands-on session, right? Yeah, so today's session is going to be more interesting. So stay tuned. Yeah, JDK 1.8 will also work, Saiteja, but we recommend Java JDK 11 because JDK 11 has the Oracle LTS, that is long-term support, right? So that's why we recommend you to install JDK 11. So we have different vendors for JDK 11. You can download JDK 11 through Oracle, or we have another sources as well. Amazon Corretto also has its own JDK 11. We have Open JDK, which from which you can download JDK 11, right? Yeah, you can use SQL Workbench, while working with your system locally, but while deploying, once you finish your web application, you need to deploy it to a remote server, right? So at that point of time, you should be needing a remote MySQL. So for that, you should create a remote MySQL account. As far as you're developing in your local system, it's fine to use MySQL Workbench debunked. Yeah, 15 will also work, but it is not Oracle long-term support. So it is Oracle STS. You call what you call as short-term support, right? So Oracle releases every new version after a period of 6 months. So they have two types of versions. We have STS and well as LTS. So most preferably, we'll be suggesting you to use LTS, right? Uh, you can use NetBeans or Eclipse, but the problem is you won't be getting the option of creating Spring project from that particular IDE. So to create a Spring Boot project through the IDE, you need to have STS only, or as well as IntelliJ Ultimate. So anyone work fine. Since IntelliJ Ultimate is not for free, we can go with Spring Boot, Spring Tool Suite. Yeah, so if you're downloading JDK 11 through Oracle, you need to have Oracle account. Yeah, sure, you can attend today's class. So yesterday there was a discussion about app modernization. Yeah, day one session recording is also available. So for this, Spring Boot track, we'll be using Spring Toolsuite IDE. Okay, so we have already given a document that contains all the prerequisites, right, for this Spring Boot track. That document clearly has all the instructions on how to install Spring. So I hope, Nikhil, you can refer that. Yeah, Docker, you have to install it, but for today's session, you don't need it. For the coming sessions, yes, you need to have it installed. I did not get your question, Girivasan. Yeah, I guess some of you have problem installing Docker desktop, right? So don't worry. We'll be dealing with how to install Docker, okay, in the coming sessions. For now, it's not required. Okay, yeah, Rohit, just wait a minute. I'll just put the prerequisite document link to the chat box so that you can refer it. It contains clear instructions on how to install Spring Tool Suite ID, right? Just wait a minute. Yeah, I guess Satish Kumar has already shared you the link, right? Yeah, that's the same link you need to follow. I'm posting it again. Yeah, so I shared you the document link. Nikhil, you can go through that and install Spring Tools ID, right? Yeah, guys, is my voice audible? Okay, great. Yeah, Gokulraj, I guess you need to install STS IDE and Java JDK 11 to attend today's bootcamp, right? No problem. Even though if you have Windows 7, try installing JDK 11 and STS IDE. So if you have those two, then you're good to go. Yeah, Eclipse will also work, but it's preferable to have STS. I already told you the reason, right? Eclipse doesn't have the feature of creating Spring Boot project. So that's why we are going with STS IDE. You have downloaded it, but you can't check version and install. So are you referring to JDK 11, Gokulraj? Okay, so first you need to go to the folder where you have downloaded the JDK 11 and open the command prompt from there. So if you have downloaded in the folder downloads, go to the downloads folder and open command prompt from there. Now Rajalakshmi, Docker is not needed for today's session, but you will be needing it in the coming sessions, like on day 3rd, I guess. Yeah, you'll be needing Docker on 3rd day. Not 3rd, 4th. Sorry, 4th day. Okay, all right, guys. I guess most of you joined. Okay, let's start today's session. Let me just share my screen. Yeah, so is the screen visible? Yeah, great. So okay, guys. Today let's start learning about Spring Boot, right? So before starting to learn about Spring Boot, let's deal with a small concept that's known as 12-factor app. So does any one of you have an idea of what this 12-factor app means? Have you previously heard of this term? 12-factor app? No? Okay. Okay. So if you didn't heard this, particular term, let's learn about this today, right? So nowadays, software is commonly being delivered as a service, right? So example, in the form of mobile apps, web apps. In case, if you consider cloud, software is also being served as SaaS, right? That is software as a service. So this 12-factor app is basically a methodology for building these kind of applications, right? So you use 12-factor app methodology for building software as a service applications. So let me tell you the 5 main features of this methodology, 12-factor app. And by the time you finish learning about this, you'll also get a clear idea of why we should learn this particular methodology and how it is important while creating software applications, right? The first feature is automated from a development perspective. So what do we mean by that? Whenever you're creating any application, right? So it should have declarative formats for setting up automation. So why do we need to do that is whenever you're developing an application, it should minimize time and cost for new developers joining the project, right? So if you started a new project and let's say some of an employee from the company has resigned, so they hired a new employee. So the software development process must be easier for that person to understand and grasp. So that's why we need to use this automation process, which will help new developers who are joining the project. And the second feature is our application must be portable across different execution environments. I hope you're familiar with the term portability, right? So portability means your application must work the same throughout different execution environments. Let's say if you consider OSs, we have 3 kinds of OS, right? That's most commonly used. We have Mac, we have Windows, and we also have Linux. So whenever you develop an application, so it should be portable and it should be able to run across any of the environments, right? So that's what we mean by portable across execution environments. And the third point is deployable in the cloud, minimizing the need for servers and server administration. So what do we mean by this? Whatever application that we are building, so it should be suitable, okay, to be deployed on the modern cloud platform. So we are having a number of cloud platforms, right? We have Azure, AWS, we have Microsoft, we have Azure, we have AWS, we have DigitalOcean, right? So, and so many. So our application, it should be in a position to be deployable in any of these platforms, right? Which means that it should obviate the need for servers and system administration. It should minimize the need for external persons, right, to deploy our application on a particular cloud platform. And the fourth one is enabled for continuous deployment with minimal divergence between dev and production. So what do we mean by this is whenever you're developing any application, there should be minimal divergence between the development phase and the production phase. So how can we achieve this? We can achieve this through continuous deployment. So what do we mean by continuous deployment is that whenever you're developing any application, so if you do a particular change in the code, the particular change should be reflected in the production as well. So that's what we mean by continuous deployment, and you'll learn about it in the coming sessions. So why do we need to do this is it gives us maximum agility while developing their application. And the fifth one is scalable without significant change or effect, which means that our architecture should be able to, we should be able to scale up our architecture depending upon the user needs. Let's say we are hosting our application in any cloud server. So based on the user traffic, our application physical requirements must be upgraded, right? So if you are experiencing more traffic to the website, then the application, then the underlying hardware capacity must also increase. So that's what we mean by scalability. Our application must scale up without significant changes that we are doing to the architecture or development practices, right? So these 5 features are what we get if we follow this 12-factor app methodology. So let me discuss about each of the factor in detail now, right? So first factor is the code base. So what do we mean by code base here? Here it says one code base tracked in revision control, many deploys. Let me explain that for you, right? And every application that you build must have a code base, and it should be always tracked by a version control system. I hope you know what is version control system, right? Yeah, so what do we mean by version control system? Version control system is basically Git. I'll give you, Git. It is a version control system. So you track all the changes that you made to your code through this version control system. So first factor is that your application code base should always be tracked by a version control system. And the next one is dependencies. So you have to explicitly declare and isolate dependencies, which means that every application has some external tools or external libraries it needs to run without any errors, right? Let's say if you are developing any web application, most frequently it will be needing a database, right? So to enter, well, suppose if you're creating any login website or login website, so users needs to register to the portal. So you'll be needing a database where you store all the user records, right? So for that, your application needs some external dependencies to work perfectly. So all these external dependencies must be managed by your code base, right? So you should have another separate file in your program which contains of all these dependencies. You should not have them in your application code. For example, in case of Java, if you're writing any class, so let's say you're making a connection request with a server, MySQL server. So what you do, we actually create a connection object, you specify the port and you write the query, right? So all this you write in a single class file. So that should not be done. Why? Because if you want to change your, you want to change your DB, you have to change the application code. You need to go to the file and you manually need to modify the code. So that should not be done because it will lead to more errors, right? So our dependencies must be in a separate XML file. In case of Spring Boot, you'll see we have a file known as pom.xml. So in that pom.xml, we declare all our dependencies, right? So our code must manage the dependencies externally. And third one is config. So what do we mean by config is that we should not hard code any configuration values in the code base, right? Code base is basically your application code. repository where you store all your application code, right? So all that comes under code base, right? So you should not hard code any of this configuration in your code base. This 12-factor app methodology suggests saving all these configuration values in environmental variables, right? You need you create another configuration file and store all those external configuration in that file. Okay, so that's what we mean by this config. I hope you got idea about what is code base, dependencies, and config, right? Yeah, now let's move to the next one. So the fourth point is backing services. So every app needs some external applications to work perfectly. That's what we previously discussed in dependencies, right? So 12-factor app can automatically swap the application from one provider to another provider without making further modifications to the code base. Let's say if your web application is using MySQL DB as the database. So in future, you decided to migrate your database from MySQL to Aurora, or you can say you wanted to shift to MongoDB. So for that process, you should not, edit your code manually to shift particular database, right? So you should have a separate configuration file which takes care that for you, right? So you should not go and edit the code manually. That's what we mean by backing services. The 12-factor app must be able to swap from one provider to another provider without making further modifications. And the fifth one we have is build, release, run. So whenever you're building an application, it has these particular 3 stages. First one is the building stage. So in building stage, we have your application. So you take all the classes of your application and you package them as a single bundle. Okay. And that's what we mean by building. So building an application means that taking all your applications and packaging them as a single bundle. And in releasing stage, you add the configurations, all the external dependencies that your application needs, and also with the configuration files to your bundle. So you have already created a package, right? So to that package, you add these external configurations and dependencies. So that what gives us the application and release stage. And in the third state, that's in the running state, you take this application which has this configuration files followed by these dependencies, and you deploy it to a production server. So that's what we mean by this running stage, right? So we have 3 stages: build, release, and run. And the 6th point is processes. So what do we mean by a process? A process is nothing but an application which is running on a server, right? So an application must have n number of instances to meet the user or customer demands. Let's say you have one single server on which you are hosting your web application. One day, unexpectedly, a lot of users try to access your website. So what happens then? User traffic will be more, then definitely your server is not adhering to the user traffic and it will crash down. So to eliminate that particular kind of situations, what you actually do is you create multiple instances of your application in different servers. So you create different processes of your application and put them in different servers. So depending upon the user traffic, you will basically, if one server crashes down, you have another server. So you will redirect all the users to another server. So that's how you manage all the external traffic. So that's what we mean by processes. And next we have port binding. So what do we mean by port binding is our application must be a standalone application, right? So you should not, let's say, if you're building any web application, it needs to have a server, right? So most probably the servers that we prefer are Apache Tomcat, Undertow, etc. Right? So you should, all these external web servers, how do you actually do that? You actually download that particular web server and then you configure it, right, before running your application. So what this port binding says that is, you have to have all these external web servers inside your application. So that what makes your application standalone, right? So that's what we mean by port binding. Your application must have all the external web servers inside it. So that's what we actually have in Spring Boot. In Spring Boot, we'll get an embedded Tomcat server. We'll see that in the coming few minutes, right? We'll see how to create our own web server and web application using Spring Boot. And next we have concurrency. Let me just, complete all these points quickly so that we can dive directly into Spring Boot. So what do we mean by concurrency? Concurrency is similar to the point process, but the difference here is the processes. I hope you learned about what do you mean by processes, right? You have multiple instances of a single application running concurrently. So in concurrency, we have two types of scaling, that is horizontal scaling and vertical scaling. So horizontal scaling is basically creating multiple instances that is similar to processes, and vertical scaling, which means upgrading our hardware. So which one is better? So if you're experiencing more user traffic, which one will you choose? Will you choose upgrading your hardware, or will you create multiple instances of your application? You'll go for the first one, right? You'll create multiple instances of your application because it doesn't take much time. So deploying a particular application is much simple than adding external hardware, right? So you go with the first process, that is horizontal scaling. So in concurrency, you scale your application. Okay, and next we have disposability. So what do we mean by disposability? Whenever every application has a number of microservices running inside it. So these microservices communicate with one another, right? So to execute the app successfully, these microservices are communicating with one another and sharing information between them. So let's say, consider an example, Swiggy app, right? So for example, take Swiggy app. So what are the microservices Swiggy app has? So user registration, right? Users will create their accounts, and then we have food tracking, food ordering, we have payment gateways, right? So all these, each of them is a different microservice. Let's say due to some unexpected issue, the payment gateway of Swiggy is not working. So that particular microservice is not working. So what you should do at that particular point of time? So the application, you should be able to stop that particular microservice. That is, you have to kill the process that is dealing the payment gateway, so that the other processes that are working should work without the effect, right? So the other microservices running, it should have no effect on this process, which means that it should have graceful shutdown. Okay, if one process is disturbing the whole application, you should be able to kill that process so that it won't disturb the other perfectly executing processes. I hope you understood what is meant by disposability, right? Okay, and next we have dev or prod parity. So what do we mean by this dev prod parity? It is the reduction of the divergence between the development phase and production phase, right? So this 12-factor methodology suggests us to reduce the gap between the development phase and production phase as much as possible. Okay, so why we need to reduce this gap between development and production? Because whenever you're modifying the code, or if you're adding a new feature to existing code, so it should be easy to test your particular code and also deploy it in a server. So in order to make the development process easier, the 12-factor methodology suggests us to reduce the gap between the development and production environment. So the same environment that you're using in development, you have to use it in production environment as well, right? You have to make the similar requirements. And next we have the logs. So yeah, logs are most commonly seen whenever an application is running in a server, right? Logs are like vital for any application, so that you can observe what is happening by seeing any logs, right? So you have to create and save all these log files in a separate file. So in case of Spring Boot, we are having a package known as SLF4J. So that particular package is used for logging, right? Keeping a trace of all the logs that are happening in our application. So you use that particular file, you create a log file and store all the logs as event streams. So why do we need to store all these logs? Because you can get clear information about your application, right? So for that, you need to have a separate log file. And next we have admin processes. So let me give you a clear idea on what is meant by admin processes, right? So there is a number of one-off processes as part of application development. So what are those processes? You have to take care of database, right? So every 15 days, let's say you're working in an organization, you're a system administrator. So what tasks you have to do? You have to back up the database every 15 days, and you have to take care of all the computers, right? If any computer goes down, you have to go and check it and make sure that it is in a working state, right? So all those are admin processes. So yeah, any application that you're developing, so it should contain some scripts which make this admin processes automatic, like saving the database every 15 days. So after a particular point of time, your application code must be able to save its external dependencies like data migration or some other processes by itself. There should not be a third person who is going to take care of all these migrations, etc. Right? So that's what we mean by admin processes. So I hope so we have discussed about the 12 factors of application, right? Now, without wasting any time, let's go and start learning about Spring Boot. Yeah, I've got many questions here. Okay, just wait a minute. I'll just share my screen once. I hope you got a clear idea about 12-factor app, right? So why we include this particular concept is that, one thing is that why you need to learn about this 12-factor app is whenever you're developing any application, if you follow this particular methodology, then your application will be robust to any kind of external inferences, right? So your application will be able to function across any crashing of servers, right? Because if you follow this methodology, it contains all the best recommended approaches for creating a software. So if you're creating a microservices, then make sure that you follow this particular methodology. Yeah, 1 minute. Let me share my screen again. Yeah, guys, can you see the screen? Yeah, okay. Yeah, Satish Kumar, you just need to understand about this. It's just a theoretical concept. Okay, once you get time, you just refer to all these points once again. Since it's, there is a time constraint, I cannot explain it again. So please do refer it, right? Yeah. Okay. Now let's start learning about Spring Boot. So before going to that, let me ask you a question. So how many of you actually know Java? So previously worked with Java. Okay, great. Yeah, that's great. Okay, I'm seeing a lot of responses here. Okay, no problem. Even though if you have basics, that's enough for today's session, right? Okay, now today let's use this particular Java to develop web applications. Looks exciting, right? Okay, then by the end of the session, you should be in a position to create your own web application. Okay, that's our outcome today, right? Now let me share you the contents of today's session. So today we are going to deal with what is the introduction to the Spring Boot and what are its features, followed by the architecture of a Spring Boot. And next we will deal with two design issues, that is tight coupling and loose coupling. So why we are learning about these two things is to understand about the next concept, that is dependency injection. So to learn what dependency injection is, you should be having good idea about what tight coupling and loose coupling are. And next we'll deal with why should we learn Spring Boot. So we have n number of frameworks out there to create web applications. We have n number of other languages. So why are we restricting to the Spring Boot for developing web applications? And next we'll deal with the Spring Initializer. Okay, there's not a typo here, guys. It's how it looks like. And next we have Spring Boot annotations. So don't worry if you don't understand it. We'll deal it in the coming slides, right? And next, we have a hands-on session. Okay, so once we finish all these concepts up to Spring Boot annotations, we'll have a hands-on session on what is dependency injection, how to create a Spring Boot project, etc. Right? After that, we'll deal with Spring MVC and its architecture. So for creating any web applications, you need to have a good understanding about Spring MVC, right? And then we'll deal with Spring MVC annotations, followed by the model object and model and view object. And then we'll discuss about this TimeLeaf, okay, which is a template rendering engine. So basically, it is used to view, it renders HTML web pages, okay? And finally, we'll end the session by seeing what this application.properties file is, right? So looks like a lot of contents, but don't worry, guys, it's going to be a beautiful journey, right? So after learning Spring Boot, I guess your interest in Java language increases, right? Twice what you have than the usual. So, okay, going to the introduction. So the Spring Boot is basically an open source framework based in Java. So have you heard of this term open source anywhere previously? Great, yeah. Okay, great. I guess you know what do you mean by open source, right? So open source is basically a software for which the original source code is made freely available, right? Yeah. And this Spring Boot framework is used to create microservices. So what do we mean by microservices? Do you have any idea about that? Okay. So yesterday's session dealt with this app modernization and microservices concept. Yeah, that's great. Small modules, okay. Independent services, okay. Yeah, so basically what are microservices is? Microservices are small services that work together. Yeah. So it's actually an architectural design, okay, for building distributed applications using containers. So microservices get their name because each application operates as an independent service, right? So they are small services that work independently. So that's how they get their name, microservices. Yes. Yeah, you're aware with the both concepts, that's open source and microservice, right? So use Spring Boot to create microservices. And the Spring Boot framework is developed by Pivotal team. Okay. So how is the Spring Boot built actually? So it is derived from Spring framework, and it provides much simpler and faster way to develop web applications, right? So basically you are using the Spring Boot framework to develop web applications. There is this important feature of Spring Boot known as rapid application development, right? So you can develop your web application within the span of minutes, okay? You'll just see how it is done in the coming slides, right? So let me just give you a small diagram here so that you will get an overview of how this Spring Boot framework is actually evolved, right? So we have the Spring framework and also this embedded HTTP servers like Tomcat, Jetty, Undertow without this XML configuration, right? So the combination of all this will give you the Spring Boot. Okay, so you have the Spring framework, you have the embedded HTTP servers and XML configuration. So you might be getting a doubt. So what do we mean by embedded servers? Do you mean that we'll be getting servers inside a Java application, inside our Spring Boot application? I guess you might have that question, right? Yeah. So until now, just hold that question. We'll give answer to that as well. Okay. Right. Now we'll see what are the features of Spring Boot. So there are three main features of Spring Boot. First one is the dependency management. What do we mean by dependencies and how do we manage them? So dependencies are any external, libraries or packages or tools that our application depends on. So all those external libraries, packages, tools, etc. are known as dependencies. So every application definitely has some dependencies, right? So the Spring Boot manages all those dependencies for you. Okay, we'll see how that is done while we are doing the hands-on session, right? For now, just understand that dependency management is a core feature of Spring Boot. It manages and it actually simplifies the process of installing, updating, and deleting all these libraries, packages, tools that your application basically depends on. Okay. And then we have simplified deployment. So what do we mean by deployment? So whenever you build an application, so it should be deployable on any server, right? So the Spring Boot also reduces the overhead of deployment, right? So once you finish developing all your application, you just go and create a single jar file, right? So you get all the external libraries in a jar file, done. You take the jar file and run it in any JVM. That's it. Your application is deployed on a server. That's as simple as it looks like, okay? And then we have auto configuration. So this is the beautiful aspect of framework, Spring framework, right? Spring Boot, sorry. Yeah, there's some jargon between Spring framework and Spring Boot. Just understand that Spring Boot is derived from the Spring framework, right? We previously discussed that Spring Boot is derived from Spring framework along with embedded HTTP servers without the XML declaration. Okay, so auto configuration, basically Spring gives us the configuration needed to run our application with all the external frameworks, right? Along with that, we also have some extra features, right? Like Spring can be used to create standalone applications. And also we can use Spring, it comes with embedded servers like we previously discussed. We get Tomcat, Jetty, Thundertow. And Spring also comes with this starter dependencies, which actually simplify our build configuration. So we'll discuss what is this build and how do you configure this, what are the starting dependencies. Okay, in a few minutes, we're going to cover all those topics. And absolutely no code generation and no requirement for XML. Okay, well, XML here stands for Extensible Markup Language, right? Now, let's see the architecture of Spring Boot. So I hope you can see the slide, right? So we have 4 layers: database, persistence layer, business layer, and presentation layer. So one thing you need to observe here is every layer, okay, can communicate with the layer that is present either directly above it or directly below it. So if you take the case of database, it can directly communicate with the persistence layer, but it cannot communicate with the business layer. I hope you can see the bidirectional arrows, right? So here database can communicate with the persistence layer, but it cannot communicate with the business or presentations layer. Similar is the case with all these 3 layers. Okay. Whereas this business layer can communicate with this presentation layer as well as persistence layer, and persistence layer can communicate with this business layer and as well as database layer. Right. So from this, you can understand that Spring Boot has a layered architecture. Okay. Now we'll discuss what we have in each layer. So now in the presentation layer, we basically have 2 concepts known as authentication and JSON translation. So what do we mean by that? So this presentation layer, basically, it handles all the HTTP requests. So what are these HTTP requests? Hypertext Transfer Protocol. These are nothing but web requests, right? So whenever you hit a URL and click enter in the browser, so all those are nothing but HTTP requests. So those requests are handled by the presentation layer. And it also translates the JSON parameter to object. So what do we mean by JSON? It's just a simple notation, okay, JavaScript object notation. So it converts the JSON parameters to objects. So in Java, we have classes and objects, right? So this presentation layer handles the HTTP request as well as translates the JSON parameters to objects. And it also authenticates the requests and it transfers the request to the second layer that is below it. It transfers the request to the business layer. Okay. To put it simply, it deals with the front end part. So presentation layer deals with the front end part. Right. And next we have business layer. So what do we mean by business layer? Business layer handles all the business logic. So it consists of service classes and also user services provided by the data access layers, right? So let me give you a scenario. We have Amazon, Flipkart, etc., right? So each of them have their own promotional sales. So on particular, on some occasions, they announce some particular sales. So let's say you're dealing the technical requirements of Amazon. So they asked you to write some business logic so that the users can see the discounts for a particular product for a given period of time. Let's say from today is what, 13th, right? So from 13th to 15th, the Amazon had requested you to reduce the prices by some percentage. Okay. So that's what you actually, that's what comes under the business logic. The core of, the how the program actually works. So that's what we call as business logic. So that business logic is what you deal in the business layer. And we also have validation and authorization, right? So this business layer deals with the business logic. It also does validation and authorization. And we have the persistence layer. So this persistence layer contains all the storage logic, and it translates business objects to database rows. How simple it's, right? So example, let's say if you want to insert some data into a database. So how do you basically do that in Java? So you create a connection object, you specify the port, you write some query, right? So all that particular thing is eliminated in this persistence layer. You will see some really easy techniques on how to convert these objects into database rows. Basically nothing but database fields, right? So we have rows and columns in databases. So you will see how database objects are, how basically Java objects are converted to database rows in this persistence layer. And finally, we have the database. So in this, we have actual database, that's the MySQL or MongoDB, etc. So we have the actual database in the database layer, followed by you can also perform creating operation, retrieval operation, updation and deletion operations in this particular layer, right? So let me just give a recap of all this. Presentation layer deals with the front end part. Business layer handles the business logic. Persistence layer contains the storage logic. What do we mean by storage logic? It translates the business objects to database rows. And finally, we have the database. So in database, you can create, retrieve, update, and delete data, right? So that's what we mean by the architecture of Spring Boot. And next, we'll learn about tight coupling and loose coupling. So these are two main important factors that you basically need to understand before going into dependency injection, right? So have you previously heard of this term tight coupling and loose coupling? Anyone? Design issues, design patterns. Okay. Right, I guess some of you have heard and some of you didn't. Okay, for those who already know, it will be a just recap for you, and for those who don't know, yeah, please do learn it, right? Okay, it's a way to solve problem, right? Okay, I guess it's not that. Yeah, we'll learn about it, right? Yeah, coupling should be less. Yeah, loose coupling is always preferred over tight coupling. Okay, we'll deal with what's tight coupling and loose coupling now, right? So coupling is basically referred to the degree of direct knowledge that one element has of another, right? So consider in this, I hope you can see the image, right? So in this image, we have tight coupling. So if you can see as a tight coupling, consider each of this bubble as a class, okay? So each of these bubbles are, more interactive, right? So they have more coordination. So which means that the elements are very intact, okay? So coupling refers to the direct knowledge that one element has of another. So we have two classes, class A and class B, imagine. So if class A knows more than what it should know from class B, so in that particular case, we call it as a tight coupling. Example, remote method invocation. So have you ever heard of it? Remote method invocation, RMI. So you basically have two classes, right? Class A and class B. So class B has some method. So you declare an object, you instantiate class B in class A, and you invoke the particular method of class B in class A. So that's an example of tight coupling. Why? Because class A knows more than what it should know about class B. So if you change any method or any particular attribute in class B, class A also gets changed, right? So if you do change in class B, class A will also get changed. So that's what we mean by tight coupling. So tight coupling is not prescribed, basically, right? So tight coupling is bad in most of times because it reduces the flexibility and reusability of code. It makes testing much difficult, right? So testing has to be done, in a more robust way. So your application that you wrote the code, it should be able to run successfully across a number of scenarios, right? So tight coupling does not allow that test ability. So it makes code much more difficult and it impedes testability. Impedes basically prevents testing ability. It reduces the flexibility and also reusability of code, right? So that's why we should not write our code in such a way that it gets this tight coupling problem. So we should always make sure that our code is always free from this tight coupling. Our application is free from this tight coupling. And next we have the loose coupling. So I hope you can see this diagram here, right? So now you can see the bubbles are having much space and are clearly and neatly oriented, right? So now can you tell me what you can understand from by seeing this particular image? So what you can get, what idea do you get by seeing this image? Yeah, changing code becomes tight in tight coupling. Yeah, that's okay. I'm asking about loose coupling. So yeah, independent, less dependent. Yes, they don't depend on each other. Yes, that's right. Only required information is changed, shared, right? Less dependent. Yes, easy for testing, right? Okay, that's great. That's great, guys. Right. So in loose coupling, we are having less interdependency and less coordination, right? So if you have less coordination, then there's less information flow. So what do we have if there is less information flow? Our code basically is better for testing in this case of loose coupling, right? So in loose coupling, elements are mostly independent. And if the only knowledge that, let's say there are two classes, class A and class B. So if you have the only knowledge that class A has about class B is what class B has exposed through its interface, which means sharing the only required information. So at that particular point of time, then you can say that your code is loosely coupled, right? So we always make sure that we write our application in such a manner that it is free from tight coupling, and always a recommended practice to program interfaces, right? So to always program interfaces, which means that you should basically create an interface and declare all the methods in it. Whenever you need it, you just implement that particular interface, right? I hope you got an idea about this tight coupling and loose coupling. Great, right? Okay, now let's proceed to the next one. That's the dependency injection. Now, since you have learned about this tight coupling and loose coupling, let's get into this dependency injection. So it is the fundamental aspect of Spring Framework, right? In Spring Framework, if let's say we are in class A and we need an object of class B. So how do we get this particular class B inside our class A? Can anyone tell me how do we do that? Now in normal Java class, let's say there are two classes, class A and class B. We need class B inside our class A. So how do we actually do that? Call by value. Yeah, you instantiate it, right? No, both are independent classes. Yeah, you create an object of class B inside a class A, right? You use the new keyword. Am I right? Yeah. Okay. Consider that these two objects are independent. No one is a parent of another, and no one is a child of another. They're simple classes, right? There are simple classes. You need to use class B inside class A. So what is the basic approach? You just create this. Yeah, create an instance of it. Right. Yeah. So what actually happens when you use that new keyword in your class? We experience tight coupling, right? So whenever you use new keyword inside a class, okay, you experience what is known as tight coupling, because whenever you change anything in class B, class A will also get automatically changed, right? Because you are instantiating class B inside class A, right? So is there any better way to inject other classes into our, to use the other objects inside our class A? Yes, there is. So that particular way is known as dependency injection. So in dependency injection, we have a Spring container. Basically, it injects other objects into our objects. So these are known as dependencies, right? So please, the slight line between the dependency management and these dependencies, those are the external dependencies that we previously discussed about, like, tools and packages that our application code needs to run. But here dependencies, what do they refer to? is they refer to the other classes, right? They refer to other classes. Okay, we have Spring container, which basically injects objects into other objects. Let's say we have class B. Class B object is injected into our class A. So that is how dependency injection basically injects other objects into the code that we are working currently, right? So we get this object injection in this Spring framework. Okay, how is this possible? This is possible due to Spring container. We will see this dependency injection in action while creating a Spring Boot project, right? Okay, to put it simply, this dependency injection basically allows for loose coupling of components, right? So if you have loose coupling, then it is a recommended approach. So to get loose coupling of components, we follow this dependency injection, right? So by following this particular dependency injection, this responsibility of creating objects, right, that is shifted from our code. We are not responsible for creating objects. The Spring container will itself create the object. We are not worried about object creation at all. The Spring container will create an object and it will give us the object. It's not our responsibility to provide the object what we need. It's the responsibility of Spring container to give us the object that we need, right? So this phenomenon or this mechanism is called as IOC. What do we mean by IOC is that it's known as inversion of control. Yeah, so this IOC means inversion of control. So using this dependency, the responsibility of creating objects is not ours, but it's the responsibility of the Spring container to provide us the objects whenever they are needed, right? So this phenomenon is known as IOC. This IOC and dependency injection are used very interchangeably, right? So even if you're referring to IOC, it kind of means dependency injection. Okay, Spring IOC is basically a mechanism to achieve loose coupling, right? I hope you understood what is dependency injection, right? Yes, Srinivas, Spring creates, but there is another approach to specify that we don't need all the 100 objects of 100 classes, right? There are two approaches. We'll discuss that in detail while saying this dependency injection, in action, right? Yeah, basically Spring Boot will give you all these 100 objects, but if you don't need them, you can specify to Spring Boot saying that I don't need all of them. Just give me the objects that I want. Yeah, what is Spring container? Sure, let me discuss that in the hands-on session, right? So at that point of time, we'll get clear idea what is actually happening. Okay. Now let's move to the next one. Why we need to learn Spring Boot? Okay, so what is basically the point of learning all these things, right? Yeah, let me give you give you some important information regarding why we need to learn the Spring Boot. First thing is Spring Boot is the combination of Spring Framework and embedded servers, right? So that's the introduction of it. And one of the major reasons to learn Spring Boot is that it follows this convention over configuration paradigm. Have you ever heard of this one, convention over configuration? Yeah, guys, convention over configuration paradigm. Okay, let me explain that for you. So simply understand that it reduces the effort of the developer, right? So convention means spending time writing our business logic. Configuration means spending time configuring all the external dependencies of application. So let's say you're writing a web application, you don't want to spend much of the time configuring, right? So installing the packages, configuring the packages, setting the passwords, setting the users in case of DB, right? So you don't want to spend much of the time doing all this configuration part. You just directly want to go and step into writing the business logic, right? So this Spring Boot follows that convention, right? This Spring Boot helps you to spend more time writing business logic rather than spending more time configuring the project, right? And the Spring Boot, we have this dependency injection. Okay, dependency injection is also used in Spring Boot. That's one reason why we should learn Spring Boot. And this Spring Boot also has, the dynamic and robust database transaction management capabilities, which we'll deal in the tomorrow's session. Basically makes it very simple to update, to insert data into a database. So that's another reason why we need to learn Spring Boot. And you can easily integrate this Spring Boot application that you've created with other Java frameworks. Okay, so the simplification, you can also easily integrate this Spring Boot application into other Java frameworks. And it also reduces the cost and development time of the application. So these are some important factors that specify why we need to learn Spring Boot, right? So basically, if you can go and visit Spring Boot documentation, Spring Boot website, it says that with Spring Boot, your microservices can start small and iterate fast, which is basically the requirement, right? So microservices are nothing but small services which work together. So you can jump directly into creating a microservice through this Spring Boot without spending much time configuring it, right? And that's why it has become the de facto standard for Java microservices. So if you're saying that you're implementing Java microservices, then you see you're using Spring Boot there. Okay. Right. I hope you're familiar with why we need to learn this Spring Boot, right? And next, we'll deal with this Spring Initializer. So what do we mean by the Spring Initializer? So Spring Initializer is basically a URL. You can say it's a web-based tool. It's provided by the Pivotal web service. So I hope you remember Pivotal, right? Pivotal is the team that created the Spring framework and Spring Boot for us. So this is a Spring Initializer is a web-based tool that's provided by the Pivotal web service, and it is used to generate Spring Boot project structure for us. Okay. So I hope you can see some of the details it's asking here, right? So if you go and visit this URL, https start.spring.io, you will get this particular web page wherein you can see this particular structure. You have the project, you have language, you have Spring Boot version, you have project metadata and dependencies. So using all this, you can create Spring Boot project. We'll see how to create Spring Boot project using the Spring Initializer, right? Okay. And then we have, so I won't spend much time here because we'll deal with it practically. I'll just skip through it. Okay. Next, we have the Spring Boot annotations. So have you previously heard of this term annotation anywhere? Okay, right. So the Spring Boot annotations basically provide the metadata about the program. So what is metadata? Metadata is nothing but data about data, right? In other words, it provides information about other data. So these annotations basically are something similar to that of metadata. So where do we actually use these annotations in a Spring Boot? So I hope you're familiar with how to write a class, right? So if you write a class, you have to specify what that particular class does. So basically what a particular class does is what you specify in an annotation. So I have put some information regarding a few annotations here. First one is enable auto configuration. We have previously learned that auto configuration is a feature of Spring Boot, right? So this feature will be enabled to us by using this particular annotation, excuse me. So this annotation, if you use it in your Spring Boot project, then we'll get the feature of Spring Boot's auto configuration. But now it's deprecated. So we got another annotation, other than this. And next we have configuration. So configuration is basically class level annotation. So here class is nothing but a Java class, which means that you write this configuration annotation above the class name. Okay. Yeah, 1 minute, guys. Yeah, sorry. Okay. And next we have the component scan annotation, which is basically the annotation that we use when we want to scan for different classes. Okay, or basically different beans. So what is a Java bean? Right. So Java bean is basically, it's a reusable software component. What do we mean by a software component? So this bean actually encapsulates n number of objects into one object. Okay. So you can use n number of objects in a one object by using this Java bean. Right. So this Spring Boot, basically this enable auto configuration annotation, and at the rate component scan. So mixture of all these annotations is what we get a Spring Boot application annotation. So whenever you create a Spring Boot project, you will see this annotation in the main method of the our application class, right? I'll show it to you when we deal with the session, when we are dealing with the hands-on session, right? So this is the main annotation that you see. It's a combination of all these three annotations. So each annotation specifies information about what our class is going to do. So we basically write these annotations above the class name. Okay. So basically, how do you declare a class? You have a access modifier followed by the keyword class followed by the class name, right? So above that particular line of code, you specify this annotation. And next, we'll so for today's session, we'll cover the annotations that are required for creating the hands-on session. So please bear with me. And next we have the auto-wired annotation. So this auto-wired annotation is what that implements dependency injection. So when you use this auto-wired annotation, the Spring Boot will actually provide or will inject you the object that is needed. Okay. So this auto-wired annotation provides you with the dependency injection. And next we have the @component. So this is how you write basically a annotation. You have the class, you write the annotation above it. Okay. So here we are having a annotation that is @component. So what do we mean by that? What is this class actually telling us? It is telling us that this class is a type of component. So this component basically means that it is a bean, right? So this customer is a bean. So whenever you want to use this class customer in other classes, you can use this auto wired and use this customer class. Okay. So this component means that it is a Spring Boot. It's basically a Java bean. Okay. Right. So yeah, so I hope you understood about the annotations, right? So there are three main annotations, that is a Spring Boot application, Spring Boot application, @AutoWired, and @component. So these are the three that we'll be requiring for today's session, and we'll deal with the other annotations that we need as soon, in the coming slides. Okay. Right. So yeah, give me 2 minutes. Let me just set up my environment and share my screen. Until then, try to please, make sure that you're ready with your Spring Boot STS IDE and all those development environment. Make sure you have your laptops and your, you have this STS open inside, right? Because the next session is hands-on. Right now, we'll see how dependency injection actually works by creating our own simple Spring Boot app. Okay. So make sure you got your laptops ready and STS ID ready, right? Okay, give me 2 minutes. Let me just. Yeah, guys, I hope you got everything ready, right? Okay, let me share my screen to you. Yeah, 1 minute, guys. Okay, so right, I hope you can see my IDE, right? Okay, now let's create a simple Spring Boot project. Okay, I'll tell you two ways how you can actually create a Spring Boot project. I'll tell you using the STS IDE and as well as using the Spring Initializer, right? So first, okay, let me start with the Spring Boot STS, right? So you have to go to this file, right? And you have to click on new. Okay, as soon as you click on new, you'll get this drop down saying to create a Java project or Spring Starter project. So go and select this Spring Starter project, right? So click on create Spring Starter project. I hope you can see, right? Now, so as soon as you click on that, so you'll get the service URL and you'll get a default name in it. So you can give your own name to the project. Let's say I'll give a name demo, right? Okay, so I gave the project name demo. Since it says it's already existing, let me give demo underscore new, or yeah, or let me give second demo. Okay. Now we have the name. This group you can give it of your own, okay? But it's better not to change any of this. Just give your own name that you want to your project. Yeah, okay, okay. I'll just repeat it. Okay, guys. Yeah, basically names are case sensitive. Yes, depend on that. You know, whatever name you create, it will generate the project structure for you based on that particular name. It's better to use lowercase, right? Yeah. Okay. So let me start from the beginning again. So once you click this Spring Boot, STS IDE, you'll be getting this kind of pop-up. Initially, you won't be getting all these kinds of projects here. These are all the things that I've previously done. So that's why I'm seeing all this here. Okay. So just go to the file, right? So you go to this file and click on new. Okay. As soon as you click on new, you'll get all these options here. You get Java project and Spring Starter project. So click on Spring Starter project. Right? As soon as you click on that, you'll get all this. Okay. And give a name to it. So let me give this second demo. Okay, that's all. And here you are getting some options. Type equals to, you have two options, Maven and Gradle. So choose Maven. Okay. Unless you know what you're doing, please make sure that the default values are not changed. Okay. So the type must be Maven and packaging must be jar. You have actually two options there, jar and var. So select jar and then we have Java version. So click on 11. So you actually got 3 versions here. So previously you told that can we use Java 15? No, right? You're not getting that support of using 15 in Spring Boot because 15 is just a short-term version. Short-term support, sorry, STS, right? And then language, definitely Java. Okay. And then click on next. Now, so please don't click on any dependencies until now. Okay, we'll create new dependencies in the next hands-on session, which we'll be going to have in an hour or so. Okay, we'll be having another hands-on session today, total 2. So for this project here, please do not select any dependencies here because we are trying to do, we are trying to learn how actually dependency injection is done in our Spring Boot project. So now, so please, don't select any dependencies here. Okay. And just finally click on finish. So as soon as you click on finish, here you can see, right, the project gets created. So if you open that, yeah, now this STS ID predicted that this project is of type Spring Boot. So it's specified in the parenthesis boot. Okay. So if you click that, so this is how a Spring Boot project structure looks like. You will be having source, /main/java folder, and you have source/main/resources folder. You have test folder. You have the GRE system library, and you have the Maven dependencies. Previously, we talked about dependency management, right? So in this particular folder, yeah, so these are all the external dependencies that our application depends on. Even though we did not select any dependencies in the by creating project, but it still created all these things because these are all necessary for our Spring Boot application to run. Okay. So dependency management, right? So Spring Boot automatically manages. Did you install this manually, right? No, right? You did not install this manually. Spring Boot did it for you automatically. So that is what we mean by dependency management there. I hope you can see the first feature of Spring Boot in action here, right? Dependency management manages that for you. So basically, Maven is a project management tool here. Okay. So it generates the build folder for you, generates the project structure. It deals with all the dependencies your project has. And next we have the source folder. Basically, it contains the output. Once you compile your code, it will generate all the class files, etc. in the particular folder. Nothing much about that particular folder there. The main thing is you have this source/main/java folder. If you open that, you'll be getting your package name. So here my package is com.abcourse.springlogin. So if you click that, yeah, you might getting different packages here and different name of the package. So don't worry, name of the package might be different and name of the package might be different, but don't worry, make sure that your application, right? So second demo application.java is inside the source/main/java folder. Okay. It will basically be like that. Don't do any changes to the project structure. Now, if you click on that, okay, it's taking a little time, right? So this is a Spring Boot app. This is how a Spring Boot basic application looks like. We have the package name. So I hope you are familiar with Java HTML, right? So whenever you create any Java file, so first it starts with the package, and next we have the import statements, right? So this is what we have. We are having the simple. This is a plain old Java class. Okay, simple like a basic how you create a Java class. Except we are having this package and import. And one new thing here is the @Spring Boot annotation tag. Now, if you just hover it, okay, you'll be getting all these things. So, yeah, okay. So if you just hover upon that particular annotation, so you'll be getting all these things. So here you can see, right, this is of type Spring Boot configuration. So previously we discussed, right, it is a combination of three. We have enable auto configuration, component scan, right, and then target. So I guess some of it is missing. If you click on the Spring Boot annotation here, so it will show you the detailed documentation. Okay. If you want to learn much in depth, you can click on this documentation, right? So if you want to learn, if you want to see more, okay, let me just read. You can go to this open declaration here, right? You can see this particular small pop-up. So click on that, and you can see the documentation of the particular Spring Boot application. Okay. So this is the documentation, original documentation, and these are all the classes it is. Basically, it's an interface. Okay. So whenever you want to see the documentation of it, just click on generate source. Okay. So go to the annotation, and if you can come down, so you'll be getting an option here. Okay. Open declaration. So if you click on that, you'll be getting the documentation. All right. Now, so we have a class that is second demo application, right? So this is the name that we have given while creating a Spring Boot project. And next we have the main method. So execution always starts from the main method. And you already know the signature of main method, right? Now, and then we have a single method Spring application.run. So this is by default, and this is the first statement that any Spring Boot application has. So this run method basically returns us an object that is of type configurable application context. Okay. Let me just open that for you. So this run method returns us a type configurable application context. So just understand for that, for temporarily understand that it's a class, okay, that's generated by the Spring Boot project. Now, so we just don't try to run this particular file now. Okay, we are not doing anything. We're just running a simple Spring Boot project here. So make sure that you are running this particular file which has the main method. Okay, then only your application will run properly. So how do you actually run a Spring Boot project is, so you actually click on run. So you select the application, right? You select the file name with .java extension, and then you go to run as. Okay, and if you click on that, you'll be getting 4 options. So in the 4th option, you can see Spring Boot app, right? So if you click on that Spring Boot app, you can see that the project is running. So you can see, right? Let me just show you my console here. Right? So this is how a Spring Boot application runs. So you'll be getting this particular logo, right? So you'll be getting the Spring logo and you'll be getting all the logs. So you can see, right? Main starting second demo application using Java on desktop. Okay. And next we have Java no active profile set. So this is how a Spring Boot, you actually run a Spring Boot project, right? Hope you got an idea of how the Spring Boot project looks like. And now there's another thing that I missed actually. So if you see in this project structure, we have the source/main/resources folder. So if you open that, you get a file known as application.properties. So if you open that, so since initially it will be empty, so this file we'll be discussing at the end of our session, right? So while we complete our session, we'll be discussing about this file in theory. But now note that all the external configurations or all the dependencies, all the external things that your application needs, you just mention that particular things or configuration in this file. Okay, right? So today we won't be dealing with this application.properties file, but tomorrow we'll see which properties can we configure through this file. Okay, right. Now let me just go and create a simple Java class here. So let me create a class student. Yeah, guys, please. Yeah, sorry guys. Now just create a simple student.java file. So before that, I hope you understood how to create a Spring Boot project, right? Yeah, just quick responses, guys. Yeah, Hemant, can you please enable the chat for now?
It's enabled, Abhishek.
Yeah, thank you. Great, great. Okay. Yeah. Thank you, Hemant. Yeah, you can disable it now. Okay. Now let me tell you how to create a class file inside this particular package. Okay. Okay, I'll just deleting this one.
There are some queries that they are facing some problem. Can you just repeat the query, repeat your steps?
Yeah, sure. I'll do that. Okay. Guys, so you have to go to the folder, okay, that is source/main/java. Inside that, go to the main Spring Boot application. So if you see this annotation, right? So go to this particular file which has this @Spring Boot annotation. So right, you just select the file, and if you right click on it, okay, and navigate to this run as, go to this option known as run as, right? So in the run as, you will see an application known as Spring Boot app. So this is how you basically run your Spring Boot application. Now, how you actually create another class is, you go to this package and right click this package here. Okay, you will be getting an option called as new. Okay, go to this new. So go to the project, go to the package, click on right click on it, and you go to the option new. Okay, here you can find a class. Okay, click on that class. And now give the class a name. So now I'm giving a simple class name, that is student, right? And click finish. Okay, right? Now, do you understand how to create a student.java file, right? Hemant, can you enable the chat for once?
Yeah, it's done.
Yeah. Guys, okay? Right. Okay, done. Thank you, Hemant. You can disable it now. Okay. So now we created a student.java class. So can you tell me what attributes can we give to this particular student? Okay. For now, let me just give some default attributes. Every student has some roll number, right? So roll number is of type integer. So let me give that as SID, student ID. And every student has some name. So let me give some string S names. That's the student name. And every student is basically pursuing some course or the other. So right. So we'll give some course name that student is pursuing. So you might wonder why I gave private here. So this private is an access modifier. I hope you're familiar with it, right? Which means that these attributes are only accessible in this particular class. Okay. Now, so why do we need to do that? To ensure that what is the first, we have three paradigms of object-oriented, right? Object-oriented programming, to ensure that we have encapsulation and our code is free from outer inference. We are using this access modifiers. Okay. Always make sure that your attributes are private. Now, so we'll create some getters and setters for this particular attributes. So what are getters and setters? So basically they are nothing but methods. So these methods can be public. So outer class must be able to access these variables using the methods, but not the attributes, right? So the outer class should not be able to access our variables directly, but rather than directly accessing it, it can access through the methods known as getters and setters. Now, if you want to set the student ID, so what you can do, you have to create a method, right? So public void let's say set SID, student ID. What parameters does it take? It takes integer ID, right? Now, and so how do you assign this particular ID to this SID attribute? So you call this dot SID equals to ID. Done. So this is how you basically create a setter. Okay. So now this setters and getters, you have to create the setters and getters for all these three variables. Now, rather than typing it, there is another best approach. There is some feature in this STS ID you can use to automatically generate the setters and getters for you. So how you need to do that is, you have to right click. Okay, just click somewhere inside this particular student class. Okay, and right click on it and go to the source. Okay, now let me tell it once again. So click anywhere in this class. Okay, and then right click on it and go to source. Now, if you go to source, you can find a number of options here. In these options, go to generate getters and setters. Generate getters and setters. Now, if you click on it, so let me say, so it's saying the select a field which is not declared as type variable or a type that declares such fields. Okay, let me just, I guess you have to select on particular variable and go to source, click getters and setters. Right, my mistake, guys. You have to select any particular variable here. Okay, and right click on that particular variable, not anywhere in the class. You have to go to the particular variable name and right click on it and go to the source. In the source option, go to generate getters and setters. So if you click on it, so you are getting all these things, right? So you have to take all this one. But make sure you check the course SID and SNAME. Okay, so make sure you check all of these fields and then click, 1 minute, and then click on generate. Done. Now Spring Boot will, this IDE will automatically generate the getters and setters for your variables. Okay, let me just put this in the top. Yeah, guys, hold on for 1 minute. Right. So public or private? Yeah, the variables must be private. Always private. Okay, so let me just repeat it once again. So how to create the student.java is go to the package. Okay, right click on the package, and yeah, the package is located inside source/main/java. Okay, in this folder you have a package that starts with com dot followed by your package. Each and every one of you might have their own packages. Okay, don't worry if your package name doesn't look similar to mine, right? Just go to the package and right click on it and go to the new option. Okay, in the new option you'll see the class here. Click on the class and you'll get this prompt asking you to enter a name. So give a name here, student or anything, that any class name you want to give, and click finish. Okay, let me create another class for you, hello. Okay, and if you click on finish, the class will be created for you here. Okay, right. I'm just deleting it because I don't need it. For getters, the getters and setters, the method is always public. So methods are always public, whereas the variables are always private. Okay, so how you actually do this is, to get all this overhead out of you. So how you actually do is you manually don't type it, just go to a particular variable and right click on it. Okay, and go to the source. So if you go to source here, you'll get an option known as generate getters and setters. Okay, if you click on that, yeah, since I already have them, it is showing that this already has all getters and setters. Let me delete that for you and show it to you again. Okay, you have to select, you have to hover on any variable here. So I'm going to sname, right click on it, go to source and go to generate getters and setters. If you click on that, make sure you select all the variables. Now here you can see we are using 3 variables, SID, SNAME and course. So checkbox, tick all of them and then go and click on generate. Okay, in the bottom you can find generate. So if you click on that generate button, so it will automatically create all the getters and setters for you. If you are still typing it manually, make sure that you follow the naming convention. Okay, the first letter must be small for declaring methods, right? So the method name must be small, and any other word after it, the first letter should be capital. Okay, the starting letter must be small letters, that is the lowercase, and any other word after the starting letter you can give it in a uppercase, right? And the methods must be public and variables must be private, right? Okay, now save this. If you actually get a star here whenever you modify the code. So okay, I hope you can find the star here, right? So now, so make sure that you save the file by clicking Control S. Control S, that hotkey, if you press on it, it will automatically save. Okay. No, you can give any variable name of your choice. It's not mandatory that you use the same variables as I've used. You can give variable names of your choice. Okay. Right. Now, okay. Yeah, now comes our main concept, dependency injection. Now, how do you want, now let's say you want to use a student.java class inside this our main Spring Boot application, that is second demo application class. So how do you do that? So how do you use this particular student class inside our application? Okay, to make sure it's clearly understood, let me create some temporary method, public void display. Okay, it's just a temporary method to make sure that we are accessing this particular student class through the through other applications, other classes, right? So create some method display, and let me just put some text here. Let's say in student class display method, right? Okay, so I'm just creating this display to check whether our student.java class, we can access student.java class through this second demo application.java class. Okay, so yeah, I hope you understand it. You can give any method of your choice, doesn't matter. It's just to check whether we can access this class student inside this second demo application class, right? Okay, yeah, Spring containers will be explained once we actually get into the topic. Yeah, please bear with me, right? Now, so how do you actually want to, if you want to use the student class inside this second demo application class, how do you do that? So can anyone tell me? Now I want to call this method display through this second demo application. So can anyone tell me how can we do that? Using public methods, okay. So now object, okay, right? That's right. So you have to instantiate the class. So how can you instantiate? So you have to say student is equals to new student, and then you have to call the display method here, right? So this is how you actually, create an object and access the student. Yes. So this is how we basically do, right? So we have to create an object and then we have to call the particular method upon that instance variable. Here I'm using S. Now let's run and check whether we are getting the output. So what output we should get here? We should be getting in student class display method. So we'll just check whether we get that method, we get that output in our Spring class, in our console basically. So I'm just running the Spring application. Right, I hope you can see, right? We got the output in student class display method. So this is how you basically use other classes inside your present class. Okay, so this is how you basically do. Now, so how does Spring actually do that? So whenever you're creating a new, you're tightly coupling these two classes. You're coupling this student Java class and second demo application.java, right? So this should not be done. So is there any other way we can actually use the student.java inside our second demo application class? Yes, can anyone answer? How second class, please explain again. Okay, yes, the method is basically injection. So we are doing nothing here, we are just instantiating the student.java class, okay, and calling the method display. Since display is of type void, it does not return anything but just prints the statement here, right? Since this method is public, you can call it from any other class. I'm creating a object S and I'm calling the method on that particular S, right? Now, so there is another approach known as injection. Yeah, someone here already told, that's dependency injection. So the question is, how can you use this student.java class inside this second demo application without using the new operator? You want to call the display method without using the new operator. Can you do that? How can you do that? Okay, great. Yeah, someone previously told that injection. Yeah. So dependency injection is what that gives us all these classes without using the new operator. So I already told you why we don't use this new operator, because whenever you use new operator, then the two classes will get tightly coupled. Now the second demo application and student class are, they both are tightly coupled. So to make sure that doesn't occur, you use this dependency injection, which is basically a feature of the Spring Boot. Now, So previously I've told you this run method basically returns this object, right? That is configurable application context. You remember, right? This run method is returning us some object that is of type configurable application context, right? Do you agree with me, guys? Yes. Okay. Now let me just try to catch this particular object using some variable. Okay, let me create. Okay, what I'm trying to do is I'm trying to catch the particular object it's returning through this method. So to catch the particular object, my object should be also of the type configurable application context. So what I'll do here is configurable application context equals to, okay. So did you get what I'm doing here? I'm creating a variable of type configurable application context. Why so? Because this method run returns us that particular object. So hence I'm creating a variable of type configurable application context, and I'm giving some name to it. The variable name is context. Okay. So now this run method, whatever object that this run method returns, is held in this context variable, which is of type configurable application context. So don't worry, even if you don't understand this, to make sure that you learn how dependencies injection is actually done, I'm showing this. Okay. Yeah. Now it is highlighting in red, which means that Spring Boot, basically our JVM doesn't know what this configurable application context is, right? We did not create that class anywhere. We need to import it. So from where we need to import it? We need to import it from org.springframework.context package. So click on that. Okay, if you click on that, you will get a new import statement here. That is, yeah, here you can see, right? Spring framework.context.configurable application context, right? So you'll get the import statement here. Hope you understood, right? So why aren't we using this new operator? New operator is because whenever you use new, you'll be getting the two classes will be tightly coupled. So we won't use new operator. Okay, we discussed tight coupling in previous slides, right? Now, okay, now we have this context. So can we, just basically, let's try to access this particular class through this context variable. We'll just check whether we can get this particular, we can run this demo display method through this context variable or not. So let me try context. Get B. So let me give the student dot class followed by s dot display, right? So yeah, let me explain you what I'm doing here. Yeah, 1 minute, guys. Yeah, so what I'm actually doing is I'm returning whatever this the object that this run method is returning. I'm holding it in a variable context, and now I'm using this context to get this student.java class. So yeah, I'm just trying whether we can access the student class through this method or not. Okay, let's just try. So yeah, before doing that, let me just tell you about this getBean method. So this getBean method basically gives us all the other classes that are present inside our Spring Boot application. Okay, we just need to specify the name of the class. So what is the class name here? Our class name is student, right? And we need to append it with the dot class extension. Okay, the class name followed by dot class extension. So we do that, and why are we doing this? Because we are trying to instantiate this student. Okay, we are trying to instantiate the student without using the new operator. Why we are not using the new operator? To make sure that we won't face a problem with this tight coupling. Okay, now after getting this variable s, okay, after getting the student class, I'm just trying to call the method s.display. Let me just check whether this works or not. Okay, I'm just trying. Let's see. Yeah, I hope you can see what happened, right? So it's saying that no type com dot student, right? I hope you can see the error, right? Yeah, did you all see this? Yeah, yes. So I wantedly run this so that you can see this error. So why are we getting this error? Why are we getting this error is you're asking Spring Boot to give you a student dot class, but you're not specifying, okay, whether it is of type bean. Okay, it's not of, it is just a simple class. It's okay, plain old Java object, right? So basically a simple class. It's not a Java, it's not a Spring Boot component, or it's not a, yeah, 1 minute, guys. Yeah, guys, sorry. Yeah. So you're asking Spring Boot to give you this student class, but what you actually see is, so how can Spring Boot get an idea of, you know, he's just asking me a class, but he's not specifying where it is or what kind of class it is. So to make sure that Spring recognizes this class and injects it to our code here, we use an annotation. Okay, we use an annotation that's known as component. Right? Previously we discussed this while in the slides, right? Yeah, someone also asked at the rate annotation, what is that and why we use? So we use annotations to represent, okay, the information about a program. Now we are telling Spring Boot that this student is class which is of type component. Now this Spring Boot knows what components are. So it can, whenever you ask this context variable to give you the bean of type student or class, now Spring Boot knows because you telling it explicitly that it is a component. Since Spring Boot knows what components are, it will fetch that and give that for you. Okay. Now we are not creating the object here. Spring Boot does that for you, right? Now you can see this error popping up. It's highlighted with red color. So how to get rid of that errors? We have to import the particular component because by default JVM doesn't know what is @ component is. You have to import it from org.spring-framework.stereotype. If you click that, so that particular import statement will be written, and now your program will have no errors. Now just save this, and now let's run and see whether we get the output, that is in student class display method. We'll see whether we get the output or not, right? Okay, so I'm just running this now. Great, now we got the output without any error. So now you understood, right, what do you mean by @component? So why we use it? So we are specifying the Spring Boot that the student.class is of type component, which Spring Boot basically gives you whenever you ask for it. Okay, whenever you ask Spring Boot, just give me this student.class object. Done. Here you go. It gives it to you. Okay. Yeah, 1 minute. Just hold on, guys. Sorry. Yeah, okay. Let me just slow down a bit. Okay. Yeah, recordings will be shared. Yeah, okay. What error did you got, Srinivas? Yeah, what's the function get bean? Okay. Yeah, I'll repeat. Srinivas, what error did? Yeah, resolved. Okay, right, great. Now, so yeah, let me repeat it once again. How to use constructors? Yeah, I'll show that as well. But I won't be explicitly telling about constructors, but I'll create one constructor to tell you how objects are created. Someone previously asked, right? If I have 100 classes in my Spring Boot application, does Spring Boot give me those 100 class objects even if I need to? Yeah, to explain that concept, I'll use this constructor. Okay. Now, yeah, I'll just repeat this. So what we are basically doing is this run method here, okay, which will return us an object of type configurable application context. So we are holding that particular object in a variable known as context, which is of type configurable application context. Okay. Yeah. So we are holding the whatever object that Spring application is returning us. 1 minute, guys. Yeah, sorry. Yeah, how do you get import function? So import function is basically, right? So it is basically our STS ID is somewhat intelligent. You know, whenever you use any class without creating, you know, without importing its particular packages, it will directly pop out saying, you know, it will highlight it with a red line. Yeah. So whenever you get that particular red line, let me show that once again here. Okay. Now I remove the import statement. Now you see, right? So if I just hover on that particular error, it is showing me 6 quick fixes are available. Okay, so but these 5 are not the ones that I needed. So the first one is what I need, that is import component, that is org.springframework.stereotype. So I click on it, then it will import the package. Okay. But a JR15 is used. Okay. Make sure that you got JDK installed previously, Pavitra. So you have to have JDK 11 installed. Then you will resolve this error. But why are we using the get beans? Yes. So these get beans are what, you know, we get from the Spring framework. You are using a Spring framework, right? So these get beans are provided by Spring framework for us. So we are using that, and to eliminate this tight coupling while accessing objects of other classes. Okay, we are now eliminating the tight coupling and also getting a desired output. So that's why using getbeans. But even getbeans also we won't actually use. I'm just showing it to you how Spring injects objects into other. So this is basically how Spring framework does it. Spring Boot also has another, you know, the simplest approach. Spring Boot is basically dead easy. You know, it makes you writing code very much easier. Even you don't need to write this much code. Just one line. Okay. Yeah, got it. Yeah, I'll tell you what's the simpler part. First, you need to understand this get bin method. So, okay, how we can inject using get bin method, and then I'll go to the next annotation and tell you, can we make this process simpler, much simpler, right? Okay. So now get bin is working. Can you tell me how we made get bin method to work? Yeah, can anyone tell me how we made get bin method to work? Previously we got error. So what did we add? Yeah, we used annotations, right? We used @component annotation. @component annotation is provided by Spring Boot for us. Okay, if you use @component annotation above any class, this tells the Spring Boot that okay, this class is of type component. So if someone asks you for this class, so just give that to them. Okay, Spring Boot here is what auto configuring it. So it will create objects by itself and it will provide them to you. Yeah, import you have to add, yes. But make sure that if you add the component, you can automatically, it will you have to, this import will automatically pop up to you. Right. Okay. Great. Yeah, glad that you understood. Now let's move on. Okay. So far so good. So is there any other alternate method? Okay, now let's create another class. Okay, right, and let's create another class. Before that, someone previously asked me, how to use constructors here? Yeah, you'll be getting 5 minutes break. You know, once we finish this dependency injection concept, yeah, we'll be given some break and then we'll resume the session. Just bear with me, guys. 5 to 10 minutes. Okay. Now, this is somewhat very interesting topic. So, haven't you guys, get it out how actually this object is being created for us? We're just going and asking Spring Boot to give us the student.class. It's giving us, but where it is creating the object, right? So, but where it is creating the object exactly? We are asking it to give us the class. Yeah, you might have got that right. Right? We can pass any value to student class from second demo. Yes, yeah, container is what that provides this student object to it. To check when this student object is basically created, let me just add a constructor. Okay, oh, let me public student. So a simple constructor, guys, nothing much. Object student created. Yeah, this, I hope you remember, right? Constructors are only invoked when the object is created. So we will get to know when if we get this particular output in the console, okay, we can understand that object is being created, right? Now, let's just run this and see whether our object is being created or not, or directly we are getting the output. So most probably we won't get the output without the instance, right? So let me just run it. Okay, I hope you can see it. Object student created, and then in student class display method. Okay, so first it's creating the object for us, and then we are using that particular object through context.getBin method, and then we are displaying the output, right? Yeah, you can pass parameters. Okay, if I want to pass parameters for constructor, what can I do? Constructor does, yes, it has a return type, but that's not the scope of this particular session, right? So we'll understand about dependency injection, and while dealing with, web application, we'll see. But most probably web application, we won't be using constructors, right? So we'll be using constructors in programming, basically while solving problems, etc. Right? So for creating enterprise web applications, constructors are not most frequently used, but there are some scenarios. Okay. Yeah, I'm just using this to explain you about dependency injection. Right. Now, yeah, let me create another object of same type. Okay, I will again request the Spring Boot to give me the object. Okay, same object. Yeah. Oh, so okay, let me create a new object. Sorry, new instance. So same. Okay, we have two instances of student class. First instance is yes, and the another instance is yes2. Now, can anyone tell me? So we are using, we are creating two particular instances of it. Do you think that Spring Boot will create the student object 2 times or 1 time? We are specifying to give us 2. 1 time, okay. Once. 1 time. Once, okay. 2. Yeah. Still, any more answers? So if you think, yeah, we are using 2 statements, right? Most probably we'll be getting 2 objects. Don't you think? Okay, I think 2, I think 1, 2, okay. Okay, 2. Yeah. Great. Yeah, thanks for the responses. Now, let's see what actually happens. So if object is being created 2 times, then we have to get this prompt 2 times, right? Object student created and object student created. We'll just see how many times this Spring is actually creating the student.java or student object for us. Okay. Let me run. Okay. This is peculiar, right? So we are asking, we are creating 2 instances, but we got only, the object is created only once, right? So the object is not created 2 times, but it is created only 1 time. If we need to, we have to create 2 classes. So why do you actually need to create 2 classes, right? So if you have one object, basically what Spring does is, even in Java, we have the concept, right? So whenever you create a class and you assign different instances to the class, you won't be creating another operator, right? You won't be creating a new memory space inside the, memory of a computer. What you actually do is, our variables just reference the already created object. So only when you use the new operator, we'll be getting new space, allocated in our memory, right? I hope you're familiar with that concept. Yeah, only when you use new operator, we'll be getting to, our memory will be allocated to our object. So, but yeah, that's basically in case of Java SC. Now we are dealing with Spring Boot here. So what actually happens here is, Spring Boot basically creates this object for you in this particular line itself. So when the 11th line of this code executes, you'll be getting your Spring Boot, your student object here, right? It gets executed, object is created once and it is stored inside the Spring container. So now Spring container has this object known as student object. The Spring container now has student object. Now, no matter how many times you refer the same object using different instant variables, it will create the object only once. If you're referring to the same object, it will create only once. But if you're differing, if you're referring to different objects, it will create the different object as well. Now let's say every student, basically, if you're a computer science student, you'll be needing a laptop, right? Now let me create another laptop class. New class. Let me just give laptop, right? So basically, what does the laptop have? Can anyone, quickly type 3 to 4. S1 and S2 are different instances of the same object. The object here is student, right? You're just referring to a single memory instance using 2 references. RAM, CPU, model, okay? Right, I've got it. So let me type private string model, right? We have RAM, that is capacity, RAM space, okay? Private and hard disk. Done. Now let me generate the getters and setters for this as well. I'm just generating this to make sure that you understand that we can generate code without actually typing. Okay? Not all, but in this case, for creating the setters and getters, we're actually not using, if you have seen in the previous class, we're not using any of these methods, but we have just created that. So just to make sure that you understand, if you don't want, you don't need to create. Okay? Now let me create a constructor to this laptop just to check whether it is when it is created. System.out.println laptop object created. And let me give it a method. What to basically use laptop for? If you are a computer science student, you'll use it to run programs, right? Public void execute. So then let me just give some method here. Code executing. Right. Okay. Now what do we need to add extra? What do we need to add to this class laptop in order to make sure that it is generated to us by Spring Boot? Yes, annotation. What annotation is that? Yeah, @component annotation. @component annotation. Sorry, there should be no space. You can give one above it, but not below. Let me import that. Right. Now it's done. Let me create this laptop object here as well. So you can use one context, a variable to get any class that you want. So let me type laptop, right? Laptop small context dot get bin of laptop dot execute, right? Okay. Import component. Yeah, great. Now, so let me just run this, and can you tell me what output will I get? So basically, let me just show you the code here. Can you expect what output I might get? 2 object created, okay, and we'll be getting 2 outputs, right? One is for the display method and one is for the execute method. Okay, let me just run this now. Right here you can see, right, laptop object created, object student created, in student class display method and code executing. So this is how you basically create objects from different classes and use them inside your class. Now let me do something here. Okay, what I'll do is let me just remove the comment this particular laptop class. Now can anyone tell me how many objects are created now? 1. Okay, 1 object. One object, 2 objects, 2, 1, 2. Okay, maybe it will show an error. Okay, 1. Okay, right. Let me run this and check how many objects are getting created. Okay, peculiar, isn't it? 2 objects are getting created. Even I did not require the second object. I'm not using it. So, but I'm not using it. But Spring Boot is giving, and it's creating the object for me, even though I'm not using it. So, what is the point of creating object if I don't need it, right? Yeah, they're objects. Yes. So it's creating those 2 objects for me, even though I'm not using the second laptop object, it's creating that for me. Yeah, it's defined in the correct component. Yes, every class that you define in that component will be generated, its particular object will be generated inside a Spring container. Okay, what is actually happening is we are having a Spring container. Imagine it as a rectangular box. Okay, initially we had student.java. So when we are accessing this particular method, okay, what basically happens when you create this student.java classes, student object is created and it is stored inside a Spring container. Okay, now draw a small rectangular box and imagine it inside the big rectangular box. The big rectangular box is the Spring container and the small one is the student object. Okay, it will be getting created for you because you specified at the rate component annotation here. Now, as soon as you create this laptop class with the annotation at the rate component, it will also generate this laptop object and it will place it in the Spring container. Now the Spring container has 2 objects. No matter whether you use them or not, it will definitely generate those 2 objects for you. Even though if you don't need it, it will have the object inside the Spring container. Okay, why this happens is that Spring container has 2 structures, that is at the rate, basically it follows 2 types of structures, that is singleton structure and prototype. So if you are using by default, we follow the singleton structure, which means all the objects are created even though you don't need it, right? Even if you don't need it, it will create an object for you. If you specify the rate prototype, then the particular object will be created if and only when you need it. So if you're having the student and Java class and laptop class, so you're having 2 classes, and if you specify one of them to be as prototype, then it will create the particular class if and only if you need it. Okay, just using annotations will print the same. We need not create same objects again. Yes, you're not using a new operator here, right? So this is basically how this context.getBin works. Yeah, that's what you can say. So that's for you to try out. I told you, right? We can use the prototype And prototype structure, prototype annotation, actually it's an annotation known as prototype. You can explore that in Spring documentation, which I'll be sharing it. I have got less time. I have to cover much more topics here. Okay, finally, we'll just, if I want student object alone, I didn't get you, Sri Ramakash. Make sure, Mr. Girivasan, make sure that you are specifying, configurable application context with no type errors. Make sure that you're creating the instance of same class. Okay, yeah, no issues. We'll have all this code in our report. Okay, we'll share this with you again, right? Since there is less time, I need to speed up things. Yeah, so I hope you understood, right? So how these objects are being created. Now, even this is somewhat complex process, right? We why to create a get bean and all these things. Is there any other still simpler way? Yes, there is. So we'll discuss that now. Okay. I don't even want this context as well. Nothing. Don't even want this. Don't want to catch the object that this dot run method is returning. I'll just remove this import because it's not needed. Right now, this is our simple plain old Spring Boot application. Yeah. Now I want to create this student rep object here. Student. So there is an annotation known as @auto-wired. So which will basically inject. So this auto-wired basically injects the student class into our second demo application class. If you specify @auto-wired, okay, this annotation injects this class into our second demo application. Now you can run any method of the student which is public. Now let's just import this auto-wired package as well. Okay, auto-wired is another Spring Boot annotation, right? Sorry. Okay, so you basically have to use this inside the student.java class. My bad, sorry. Yeah, before dealing with annotation, let me give you a scenario. Let's say basically students want to use laptop, right? Second demo application.java, it doesn't need to use a laptop. So that's just simple class. Basically, student needs to work with laptop. So student class is dependent on the laptop.java class, right? So we have to use this laptop.java class inside our student.java student class. So how can we do that? So we can use @auto-wired annotation here, and we can inject this laptop.java class inside our student.java class. How can we do that? So you just use the you just use the @auto-wired annotation followed by the class name. And what does this laptop has? Let's say we'll run some method void execute. Okay, we'll execute the code inside this inside the student class. Yeah, just bear with me. If you don't understand, I'll just explain again. What I'm basically trying to do is I'm trying to use this laptop class inside this student. Basically, I'm trying to instantiate laptop class inside the student class and execute this method. That is, this is the same name. Let me give compiling. Yeah. I want to execute this compile method of laptop class inside this student.java file. Okay. So this auto-wired is showing error, which means I have to import this annotation. I imported it. Now it's fine. Yeah. So I can now use this laptop. Now I can run any of the public methods of this laptop class. So let me just run this compile here. Okay. So this is how you basically do it. Sorry, I guess there's an error. Okay, let me just put it inside this display method and try. Yeah, it's working. Sorry. So it should be inside a method, right? So whenever you're calling any method, it should be inside another method. You cannot directly, right? Inside a class, you cannot. So you have to create another method and execute this inside a method. My bad. So here I'm creating the object. Sorry, I'm getting the object which will be given to me by Spring Boot. Why? Because I'm using iterate auto-void, which will basically inject this object laptop into my student class. Okay, and I'm trying to compile this one. Now let me just run. Yeah, is disallowed for this location is basically whenever we're creating any web application or any project in Spring Boot, we don't mess with this main method. Okay, it always remains static. So just for demonstration purposes, I've created and edited this one. So basically, this will be static. You don't need to change at least one line or one character of this file. Okay, it needs to be static. You don't mess with it. You have to create new modules and you have to create classes inside this. Right? So you basically don't do that. Auto-void is basically disallowed for this. Okay. Now, let me try and run this one. Okay. So now, yeah, still, I'm not creating, if you can see that, I'm not using the student.java, right? So student object that is returning to me by the Spring Boot, I'm not using it here anywhere. So that's why we are unable to run this method, that is display. Okay. So to run this display, let me, just hold that object and run it for you so that you'll see application. Yeah, this is just for demonstration purposes, guys. We'll take a break within 5 minutes. I'll just close it. And then in the next hands-on session that we'll be having after 722 or 725, we'll deal how to create a Spring Boot web application then and there itself. It's very easy. So this dependency injection is what very important. Okay, why I'm creating this run, this context method again is just to make sure that you see this auto-void being implemented. Okay. So yeah, previously this object got created. That's fine, no issues. But this method did not execute. Why? Because we are not, manually executing this method from any other class. So that's why I'm creating a student instance here, and then I'm calling the method display on that instance. Okay. So let me just run this one. Yeah. So now you can see, right? So the objects are created in student class display method. And from this student class, we are invoking the method of this laptop class. Why laptop object executes first after the student. Okay, great. So why it does this is, let me create another class so that you'll get more idea. So class a bag, student also needs a bag, right? Finish. Okay. Let me wrap this up quickly. Component. String model. And we have color, right? Private string color. We'll create some constructor. Yeah, you have to understand that I'm actually specifying constructor access modifiers to each and every variable and method that I'm creating. It's actually a good approach to always specify access modifiers, right? Make sure you also inculcate that. Yeah, since I'm not using modal or color variables, it's showing this warning. Nothing to worry about. Now, let me run this again. Yeah, can you see the difference now? Yeah, default access specifier is there. That's in the same package, right? So yeah, default access specifier, you can, yeah, for now, it doesn't matter actually if you use any kind of access specifier. But when you have this back.java inside another package, then definitely you need to give some access specifiers to it. Yeah, it's alphabetical. Back class not executed. So why? Because we are not creating any method, right? We are not calling any method here, but we are writing some constructor. That constructor is being executed, right? Object we got bag object created. So I hope you got your doubt clarified, right? So Mr. Sri. Yeah. So it executes in alphabetical order. Okay. So that's thing. Yeah. Hope you understood what do you mean by dependency injection, how objects are injected from one class to other class, what is component and what is at the rate annotation, right? At the rate automated annotation. Okay, let's take a break for 10 minutes and then we'll rejoin the session. So next session is going to be the part where you actually build web application. Yeah, Mr. Girivasan, you can, just post your error in the Telegram group. Okay, our mentors will be helping you resolve that error, right? Yeah, since we don't have time here to resolve it, so hope you understand. Great. Okay, yeah, guys, you can take a 10 minutes break and then we'll resume our session at 7:35. Right. Okay, guys. Yeah, guys, let's wait for another 3 minutes until 7:35. So till then, if you have any doubts until the topics we've covered, you can post it in the chat. Yeah, Pawan, I'll share the document once again. Yeah, I've shared the document link. Pawan, you can go through it and finish your installation. Yeah, so I guess is everyone back? Can we start now? Okay. Yeah, great. Yeah, great enthusiasm, guys. So now comes actually the beautiful part of creating web application. It's so easy and so fast, right? So a couple minutes of theory and then we'll just dive right into creating a web app. Okay. Okay, then yeah, let's resume a session. So for front end, you can use HTML or JSP, whichever you're comfortable with. But in this session, we'll be dealing with only HTML. Since most of them are comfortable with that, we choose to go with HTML. If you're familiar and good enough and you want to use JSP, you can. Okay, right. Let me just share my screen. Yeah, 1 minute, guys. Okay, I hope you can see the screen, right? Great, okay. Yeah, let's resume a session. And the second part of session is going to be Spring MVC. So the Spring Web MVC or Spring MVC is basically a framework, right? So it gives us the model, view, and controller architecture. And it gives us some components that we can directly use to develop web applications, which are, by the way, loosely coupled. Okay. So it's basically a software architecture pattern which separates our application into three parts, right? That is the model, view, and controller. Okay, and this MVC provides a loose coupling between all these three elements. Now, so what is basically the model? Model encapsulates the application data, and in general, what is basically a model? Model is basically a plain old Java object, POJO. So basically simple class file. Okay, so a class file is known as a model, or basically an object. Okay, you can consider model as an object, right? And then we have the view. So view is basically HTML page or JSP page, anything that the client's browser can render. Okay, so we can use either HTML as a view or JSP. And then we have the controller. So controller is kind of a mediatory that based on the user input, or based on the HTTP request that is made to the server. So based on the request, this controller will give this particular view to the browser. Okay, let me just show you the Spring MVC architecture now. Yeah, sorry. Right. So this is how a Spring MVC architecture basically looks like. We have a web browser. So if you open a web browser and if you type a URL, so that particular first URL is sent to the front controller, which is actually in Spring Boot, we have a front controller that is known as a dispatcher servlet. So we have a servlet that will be running in the background. And we also, the beautiful part of Spring Boot is that there is a embedded Apache Tomcat server that will be available as part of the Spring Boot application. Okay, I'll show you that in the next few minutes. So how we actually get this embedded server? Imagine server being a part of an application. Wow, that's just great, right? So we get this particular server embedded inside our application, and we have a dispatcher servlet as a front controller. So whenever we request for a particular URL through the web browser, that request is sent to the dispatcher servlet. So which then forwards that request to the controller with the help of a model, right? So that controller then checks whether, if you are having four web pages. First one is index, and next we have about us, next we have contact. Let's say, and we have a simple blog page. So if you're going and requesting the web browser to display about us page, so you should write a controller for about us. So if you write a controller for about us, then the front controller will redirect the web browser to that particular controller, which then finally gives you the view. View is basically HTML, right? So what is the process? First, we have a front controller, which then transfers the request to the controller, which finally gives you the view, and it is sent back to the web browser for rendering. Okay, Spring MVC architecture contains of three components: model, view, and controller. Model is basically, let me just recap that once again. Model is basically, it represents a Java object which carries some data. And we have the view which visualizes the data that the model contains. Okay, that's basically the HTML or JSP, etc. And finally, we have the controller that manages the data flow into model object and updates the view whenever data changes. Okay, it basically kind of separates this model and view, right? It separates that, and also it controls the flow. Okay, so if user is requesting for this particular page, then only give him the HTML page of that particular URL which user requested. If user wants index, then only return him the index. If user asks for about us page, then only give him the about us view. That's all, nothing much. Okay, so I hope from now you can understand that for every view that we need to render, it should have a controller. Okay, now we'll deal about some important MVC annotations. I hope you understood the architecture of MVC, right? Yeah, quick response, guys. Okay, great. Now let's continue with the topic. Next, we have Spring MVC annotations. So what are the annotations that are provided by the Spring MVC for us? We have a controller, a thread controller, which basically tells the makes the class as a controller class. And next we have a request mapping. So whenever user goes and requests, basically these are nothing but web requests, that is a HTTP request. So these request mappings are used to map those particular web requests. It has optional elements like header, method, name, params, path, produces, and value. So all these are optional. So depending on your requirement, you can use. So by default, you just have to specify one parameter, that is the path. So which path is the user is actually requesting the web browser. Okay. So you have to specify that in the request mapping. Right. So here is a simple controller here we wrote. So we have the @ controller annotation at the top. We are writing a class books controller, and whenever request mapping, you can understand request mapping like this. So whenever user requests for a /localhost/home, then return him the index.html web page. Here, even though we are not specifying .html, the Spring Boot automatically thinks that user is asking for .html, and it returns the HTML page. Okay, no need to specify the extension .html. So that's another beautiful aspect of Spring Boot, right? Auto configuration. Okay, and this method here, I hope you're familiar with get, post, put, other methods, right? HTTP methods. Yeah. So basically, whenever the user requests for get method, then return him the index page. Okay, that's what we mean. Now, since we don't have much time, okay, we'll jump directly into a hands-on session, right? We'll deal with model and model view and the remaining topics for tomorrow, and we'll try to build a simple web app and with the concepts that we have learned today, right? This controller and request mapping are more than enough to create a simple web app for us. Okay, right. Okay, let me just go to my STS IDE. 1 minute, guys. Right, so now I'm in my STS IDE. Let me close this project. So previously, if you have opened your project, please close that. How can you close it? You go to the package, go to project name, right click on that, and go to close project. Here you'll be having an option, close project. Click on that. So now the project will be completely closed. Okay, right. Now we'll create a simple web application. So what is the first step for creating any web application using Spring Boot? We need to create a Spring Starter project, right? So you have to go to new. Sorry, you have to go to new, followed by Spring Starter project. Okay, yeah, am I going slow or I'm going too fast, guys? Yeah, you can understand me, right? Yeah, okay. How to delete a project? Yeah, you can delete it from the File Explorer, right? You just go to File Explorer, just find the location where the folder is and just go and delete. Okay, so simple, right? Now, give some name. Let me give as a web application demo, web app demo. Make sure the type is Maven, packaging is jar, Java version 11. Yeah, if you have some compatibility issues, if you have 8, just select 8, no matter. Okay, so if you have JDK 11, you just click on 11. If you have 8, click on 8. If you have 16, click on 16. That's it. A language is Java, and rest of them all, you just keep it as it is, and then click next. Now here is what the important part lies. So previously we did not select any dependency, right? Now we are selecting some dependency. Can anyone guess? We are creating a web application. So what kind of dependencies we might need? Yeah, here you can see, right? We need a Spring Web dependency. So the Spring Web dependency contains, yeah, I hope you can see, right? It is showing me some prompt saying build web including RESTful applications using Spring MVC. It uses Apache Tomcat as the default embedded container. From now you can understand how Spring Boot will actually give us the server as part of the web application, right? Yeah, little slow. Okay, sure. Yeah. So you have to select the Spring Web as your dependency. Okay, that's all what is needed. Tomorrow we'll deal with the other dependencies that you need. Okay. Yeah. So for displaying web page, for creating web page, we need Spring Web dependency. And finish. And let's click on finish. Now, yeah, we got our application here, right? Hope you can see. Speed. Okay. Okay. Yeah. Okay. If I can open that. So same project structure as previous. We have the source/main/Java. Inside we have a main application. So if I can see that. So the main Spring Boot application remains the same. No need to change that. Okay, you won't need to change anything. And in the resources folder, now you see if you can observe from the previous project and this project, we got 2 extra folders here, right? In the source/main/resources, we got 2 extra folders, static and templates. Did anyone observe that? Once more, please. Okay, yeah, I'll repeat. Yeah, did anyone observe the static and templates folder? Okay, new to this project, right? Previously we did not have this, we just had only application and properties. Now we got this too. Why? Because we're creating a web project. So basically every web application needs some templates to render, right? Yeah, that's correct. For HTML and CSS files. CSS you put in static folder, templates you put HTML you put in the templates folder. Okay, great. Yeah, I'll just repeat how to create a web app once again. So just go to file, click on new. Okay, go to Spring Start a project, give some name. Okay, give some name to the app, then click next. And then select Spring Web as the dependency. You won't see this actually. You have to type here Spring Web. Yeah, along with web, we have a number of dependencies basically. That's what makes Spring Boot much preferred framework for developing web application. Let's say if you are creating microservices using Java, then boom, you must be using Java Spring Boot framework, right? So if you're saying that you're creating web services in Java, then you must be using Spring Boot. Okay, so that's how it goes. So it's basically the de facto standard for creating Java web microservices. We got a number of dependencies, but today we'll just restrict ourselves to the Spring Web. We'll deal with others in the coming sessions, right? And you have to click on finish. That's it. Okay, it will generate the project structure for you. Okay, great. Now, so let's build a simple hello world web application. Okay, so if you request and if you go and type in the browser localhost colon 8080 is a default port followed by hello world, it should greet us with a simple hello world message. Okay, so for that, can you tell me what do we actually need for creating a web application? We need a model, we need a view, and we need a controller. Okay, for now today, let's create some. First there should be a controller. So how can we create a controller? Does anyone have a guess? Yeah, we store HTML in templates folder and static, CSS in static folder. Yes. Yeah, Pojo, plain old Java object, which is basically a class, right? So go to the package, that is a package that you have in source/main/java, and click on new, go to the class, click on class, and give some controller, give some name, hello world controller. Okay. So go to the package, right click on, and then select new, and then go to class, and the class give some name, hello world controller, and click on finish. Done. So now, so to make sure that this is Spring recognizes this class as a controller, what annotation we need to use here? Can anyone tell me? To make sure that Spring recognizes this class as a @controller. Great. Right. So we have to type @controller. Yeah, since we are not actually importing the package, it's showing us error. Now we have to import it. Done. So now we've imported it. Okay. So, and next what we need to add, we need to render the view. So for rendering the view, user will request for HTTP localhost colon 8080/hello world, or he will just, even if he types slash, you should render the view. How can you do that? What is the next annotation we need to use? Can anyone tell me? Yeah, request mapping. That's great. Yeah. So request mapping is what we need to use to map the web requests, right? So in this, there are many parameters you can pass, and just for the time being, you just pass a single value /home. Okay, if user goes and requests to this particular /home URL, we should give him some, we should return him that particular view. So after that, we have to create a class, public class home. So it should be public, right? Because we are calling this from outside, right? Sorry, it's not a class, it's a string. It returns of type string. Yeah, I hope you previously observed, right? We are returning the metal in double quotes, right? So the view is returning in double quotes. We are to the return type is string here. Okay, return. What are we returning? We are returning some HTML, that is home. We are not specifying .html here because Spring will automatically take care of that for us. click on request mapping, and then you import that package. Okay, yeah, hope you all did this. Yeah, remove class. Yes, that's my bad. Yeah, I've removed it. So it is the, now you have to specify the view inside the double quotes. Okay, now what are we missing? We got our controller. Then what do we need to add? Yeah, for this simple app, don't consider model. We have a model, but we are not using any of its attributes. Yeah, we need a view. Yes. So where can we create the views? Can anyone tell me? In which folder? Templates. Yeah. So go to the templates folder, right click on it, go to new, and go to file. Okay, file name is home.html. So yeah, so in this session you'll also learn how to add some external dependencies which you actually, if you forgot some app dependencies that you actually have to create, but if you forgot to include them while creating the project structure, I'll also tell you how to include that externally. Okay, now, so that's why wantedly I did not create another dependency, but we need it. So to render the views HTML pages inside our, inside the browser, we need a external rendering engine that is known as TimeLeaf. Okay, Spring has that TimeLeaf rendering engine, which we need it as a dependency. Let me show you what dependencies previously created for us. Okay, so these are all the dependencies that are for our, that we have for our current web application. We'll check whether we have that Tomcat here or not. Yeah, you can see, right? Now we got the Tomcat server as an embedded jar application. So this is what we mean by dependency management. It's having all the dependencies that it is needing inside the application, right? So whatever the external dependency it needs, all of them you got here inside this Maven dependencies package. Okay. Now, yeah, so since I missed to add that external dependency TimeLeaf, so basically I have to add it when you create a project structure. Since I missed it, let me tell you how we can add other dependencies to this project. Okay, if you forgot to do so. So you have to go to this pom.xml file. Okay. Yeah, so this is a pom.xml. From this, our Spring Boot does dependency management. Previously, I told, right, this is an XML structure, which means extensible markup language. You use this. Maven is basically a tool to build your project. Okay, it generates all the dependencies for you. Here you can see, right, we have the starter web dependency here and starter test. What it is missing is it is missing the TimeLeaf dependency. So where can we get this TimeLeaf dependency? Okay, yeah, so you have to go to the browser. Let me share that. Yeah, can you see the browser? Yes, so what you basically need to do is you have to go to MVN repository. Okay, you have to go to MVN repository on first link that you get. So this is the MVN repository. So in this, all the dependencies. So what this are, what is our web application missing currently? Can anyone tell me which dependency? Which dependencies a web application missing? Yeah, guys. Yeah, TimeLeaf. TimeLeaf. It's TimeLeaf. Right, TimeLeaf. So we have to get the dependency here. TimeLeaf and search. Okay. So in this, select the second one. You actually have select the first one, but since the second one is related to Spring Boot, select that one. So go to that, select the Spring Boot starter TimeLeaf, and version is 2.4.4. You click on that because that is the stable version here. Here you got the dependency. Click on this one and you just copy the dependency. Okay. And now we have to paste this dependency in our pom.xml file. Right. Yeah. Can you see my screen? Yeah. Yeah. Can you see it now? Displaying the Spring STS IDE. Can you see it? Yeah. Okay. So I've copied the dependency. Now I have to paste it inside where? Inside this dependencies tag. Okay. We have this dependencies tag. Inside it, you have to paste it. You can either paste it at the top or at the bottom. Yeah. Okay. I'll just repeat it once again. Okay. So since our project is basically missing the dependency that is TimeLeaf. So why we need to use TimeLeaf? In order to render HTML pages, we need TimeLeaf. Since we forgot to add it, most probably we'll do, but you have to be aware of how you can actually add external dependencies if you forgot to add them while creating the project. So that is why I'm teaching all this, right? So if you forgot to add the dependencies while creating project, you have something known as a Maven repository. Okay, you need to go to Maven repository. So let me show you my browser. Okay, so this is what you call as a Maven repository. So here this Maven repository contains all the dependencies, right? So here you go and search for dependency that you are missing, that you want. So here what we want, we are searching for TimeLeaf. So search for it. So here we got 235 results, but select the second one since it's more oriented with a Spring Boot. Okay. And then you have these many versions. In that, select the latest, and that is 2.4.4 version, which is the stable one. Okay, as soon as you select it, you have this Maven here. So you have this dependency tag here. Okay, you just click on that and copy the dependency. Now you just go back to your Spring STS IDE. Okay. Yeah, let me show my ID. 1 second, guys. Okay, now you go back to your IDE and then you paste your dependency inside this dependencies tag. Okay, so inside this dependencies tag, you just paste that TimeLeaf. So better to give some indentation, right? Okay, great. Now we got the dependency inside this. So as soon as you add some dependency to it, what you need to do is you need to update the project. So go to this pom.xml and right click on it. Okay. And then you have Maven. Select, go to Maven and click update project. Okay. And click on OK. Right. So any doubts? Can you copy it? Yeah. Okay. Let me just paste it here. 1 minute. So this is the dependency you need to add. Okay. Got it. Yeah, I did not create. Okay, hello world controller, you mean? Yeah, this is the controller. So basically a simple class, which is, we have a direct control notation and we add a request mapping, right? So now we got our external dependency here. Okay, we'll just check our Maven dependencies, whether the TimeLeaf is inside here or not. Okay, let me check. I hope you can see, right? Yeah, can you see TimeLeaf here? Okay, now we got a TimeLeaf. Right. Peter, this is the hello world controller. Yeah, I hope you got it. Right. Now, so we have our controller, we have our dependency. What we are still missing is our view. We created the file, but we did not add any HTML to it. Let me just add it. Simple page. So you can, yeah, today I want you to try it after the session. Okay, try adding some CSS, just basically start with Bootstrap. Okay, you can either use CDN or download the Bootstrap files and put them inside the static folder and design some front end, design some website using the annotations that you have learned, right? Okay, so let me just doc type HTML. That's the declaration. HTML tag, opening and closing. So simple one. Okay, so to make sure that TimeLeaf is rendered, you have to add some extra information here, that is the XML NS colon TH. So this is something like a dependency, you can say that. So this make what this does is it tells the TimeLeaf to render this page as a HTML website. Okay, you have to specify the link here, timeleaf.org. So you have to add this one. Okay, in order to render this HTML page, you have to add this one. Even though if you don't add this one, it will still work, but in the coming sessions you will be needing this. So that's why you have to add this. Not getting the template. Okay, Ruchika, I can post your error in the Telegram group. Okay, we'll see that. Still we didn't create that template, so you might get errors. Please bear with me. Okay, let's just quickly wrap this up in 5 minutes. Simple head tag. We give some title here. Spring Boot app, sorry. We have the body tag. Okay, simple paragraph tag. This is simple web app. Okay, so we got everything right. We got the view, we got the controller, and we got our application. It's time to run our application, right? Can we add TimeLeaf dependency in external way alone? I did not get you, Sri. Okay, yeah. So now let's just run this application here. Just click on run, select Spring Boot app, click on OK. So there are a lot of things happening now actually. So this is a lot of information to understand. So what it basically does is finally it created a web application, okay, in 2.168 seconds. And where we can access this application, it is on port 8080. So this Spring Boot application is creating us a server which we can access at 8080. So what URL we need to enter in order to see our HTML page? It is the /home. Okay. So now let me share my browser so that you can understand what's happening. So now let me just go to localhost 8080/home. Okay. Hope you can see the output, right? So done. Here we got a simple web app. Make sure you're specifying the port 8080. Right. Okay, I'll just show you how to run. Yeah, once again. So you go to a Spring Boot. Okay, I hope you can see my STS ID, right? Okay, what you need to do, it's currently running. Let me just stop this one. Okay, so you have to go to your project directory. Inside this, go to the main application.java, okay, in which you have the @Spring Boot annotation. Go to that file, right click on it, and go to run as, okay, and click on Spring Boot app, right? I hope you got it. So go to web app demo application.java, in which you have Spring Boot annotation, Spring Boot application annotation, right? And right click on the class, okay, go to run as and click on Spring Boot app. So that's all. So as soon as you click on it, application will start running, right? Okay, so did you get the output, guys? Yeah, got it. Great. So this is how you actually create a web application. That's it. Now it's time for you to explore. Try adding CSS inside the static folder, add some JS, explore how you can add some good front end, framework. Try to make the site more user friendly, right? Yeah, so please try this out today, and the remaining topics we'll discuss in tomorrow's session, right? Yeah, 1 minute, guys. Yeah, so if you have any queries, yeah, just quickly put them in the chat. If we can add TimeLeaf dependency when we can create a file. Yeah, we can add TimeLeaf dependency. I'll just show you that as well. So basically, why I actually kind of missed it while creating the project. Okay, so you have to go to File, New. Let me just show that to you. So it's basically simple. Okay, go to Spring Starter project. Right. So click on Next. Yeah, I'll just finish it. You have TimeLeaf here, right? Just click on it and click on Spring Boot. That's it, done. Nothing more needed. Right. So this is as simple as you do. So, okay, you got it? Right.
Abhishek, can you just show the HTML file?
Yeah,
Like
sure.
on
Sure,
first?
Hemant. Yeah, 1 minute. So guys, this is the HTML page. Simple one. So the one and only extra thing that I've added here is this notation, or this XML tag, which states the which basically makes it as a TimeLeaf rendering engine. Okay, which tells TimeLeaf to render it as a HTML web page. That's it. Okay, to access this web page, you have to go to the port 8080 in your localhost. Yeah. So why? Because you have to stop the previous application that you already started. So Varun, please go to the application that you already started, right? Previously, you might have one application running. So go to it, first stop that application and you rerun the application, right? Check what application is previously running, stop that and then rerun it. Yeah, Ruchika will share you all these, files through GitHub repo link, okay? Yeah, so still any queries, guys? So regarding today's, yeah, GitHub link, yeah, will be shared to you, okay? Yeah, right. So any more queries, guys? Yeah, so here's the feedback link. Please give your feedback and then you can leave from the meet. Yeah, please give your feedback, guys. Yeah, thank you. Let's meet again tomorrow. Tomorrow is going to be very interactive than today, right? So we'll cover the remaining topics, and also tomorrow we'll deal with the database management, how we can actually convert objects into database rows. Okay. Yeah, okay, Girivasan. I'll make sure that you get those files, right? Yeah, you will get a recorded session. Cinemas, I did not get you. Right, so please give your feedback before you exit the meet, guys. Yeah, no issues. Even if you did not submit yesterday's, please do submit your feedback for today's session. Okay, and then
Sorry to interrupt you, Abhishek.
yeah.
The recording of this session is already live on our YouTube channel, which is Smart Interns. As soon as the session ends up here, in next 5 to 10 minutes, the video will be there on our YouTube channel. Channel name is Smart Interns.
Yeah, Sheikh, you can, just go to YouTube and search for Smart Interns VMware Build-A-Thon and you'll get all the recorded sessions there, right? Okay, great. So, yeah, so that's all for today. Hope you had,